Welcome to lesson 2.5. Today we're going to continue to talk about atomic structure, and we're going to look at some atomic symbols or nuclide symbols. Through J.J. Thomson's research, we discovered the subatomic particle called the electron, and as research progressed, Rutherford actually promoted the idea of a proton because there's something positively charged in the nucleus, and then Chadwick actually discovered the neutron several years later, because they knew there was something else in the nucleus. We know the protons and the neutrons reside in the nucleus, and we know that based on how many protons, how many electrons, and the location of those electrons, as well as how many neutrons, can actually change how an atom responds in different situations. So in the nucleus is very small compared to the rest of the atom. The nucleus is very dense as well. Those protons and neutrons are very packed in there very tightly. We talked about the mass of an electron, and the actual mass is given here, mass of the proton and neutron as well. Notice the proton and neutron are very similar in mass. The electron is much, much smaller, and generally speaking, that's why when we calculate the mass of an atom, we consider the proton to be 1, the neutron to be 1, and the electron to be negligible. The charge is also listed there. Again, the charge on an electron is not actually -1. It's 1.60 times 10 to the negative 19 coulombs, but we use -1 as the charge of an electron and +1 as the charge of a proton, just to simplify what we do when we talk about an atom or an ion. And the neutron itself has no charge, it's neutral. We can have, in order to be a specific atom, in order to give it its identity, an atom will have a specific number of protons. So for example, if an atom has 1 proton, it is hydrogen. If an atom has 2 protons, it is helium. And so protons give its identity. But we do have something in the nucleus that can cause the one type of atom to be different from another atom of the same element, and that is the number of neutrons, and that gives us our isotopes. So this slide shows 2 isotopes of sodium, sodium-23 and sodium-24, and if you'll notice, both have 11 electrons, both have 11 protons, but what they differ in is the number of neutrons. And so isotopes will differ in the number of neutrons, causing them to differ in mass. When we're writing a nuclide symbol or a atomic symbol, it's written so that the mass number is on the left on the top, the atomic number is on the bottom to the left, and please note that this is incorrect. The atomic number is not 22. This slide does have an error in it. So the atomic number is the number of protons. So sodium does have 11 protons. Mass number is the protons plus the neutrons, and then this is the element symbol. A lot of times students will struggle as to which number to put on top. I always tell students to set this up like it's a subtraction, because what you're trying to do here is you're trying to calculate how many neutrons are there. And so if this was correct, it would be 23 minus 11, which would give me 12 neutrons. And so if you can't remember which number goes where, your mass number is always bigger. Well, not always. Hydrogen, it's not bigger, hydrogen 1, but most of the time it is bigger, and so that number goes on top. Critical thinking question. This is just a mathematical, and this would depend on how tall you are. If the average diameter of an atom is 2 times 10 to the negative 10th meters, what if it was 1 centimeter? How tall would you be? And so that's just a ratio for you to calculate later if you're bored. But for what you'll be looking at on the quizzes and exams, it says to write the symbol for an atom that has an atomic number of 9 and a mass number of 19. How many electrons and how many neutrons does this atom have? So if you're talking about an atomic number of 9, you're talking about the element fluorine. And so you know it has an F as its letter, and it gives you the atomic number and it gives you the mass number. And so you would write an F. To the left of that, you would have a 19 over a 9. How many electrons does it have? So far we're talking about electrically neutral atoms, which means electrons must be the same as protons. So if the atomic number is 9, that means it has 9 protons, so it would have 9 electrons. Subtraction problem, 19 minus 9 gives me 10 neutrons, and that's shown in the next slide. So there is, and that atomic symbol is correct. And to that, a lot of times this is, if you're trying to write a paper or PowerPoint or whatever, this is not the easiest symbol to incorporate into your paper or PowerPoint. And so you would call this fluorine 19, and you could even write it F-19, and a chemist would know what that means. Let's look at another exercise here. How many protons and neutrons are in the nucleus of each of the following atoms? So I'll give you a little bit of time to look at these, and then we'll kind of talk through what the answers are. If necessary, go ahead and pause the video. Because this is bromine, if you look on the periodic table, bromine has 35 protons, so its atomic number is 35 protons. We do the subtraction, so if we put a 35 down here, we get 44 neutrons, and then because it's electrically neutral, the protons are going to equal the electrons and both be 35. Notice on these symbols there's no number at the bottom left. That is because that number is actually redundant. So if I put a 35 here, 35 means bromine, but bromine also means 35, so you don't actually need that bottom number. This is an acceptable atomic symbol. Same thing in this one in terms of protons, because it's bromine, it has 35 protons, electrically neutral, so it has 35 electrons. And then if we do the subtraction, this time we added 2 to the mass, and so we're going to add 2 neutrons. The next one is plutonium. Plutonium on the periodic table is element 94, so it has 94 protons, therefore 94 electrons. We put a 94 down here and subtract, and we get 145 neutrons. And then the last one is cesium. Cesium's element 55 protons, 55 electrons. Do the subtraction, we get 78 neutrons in that isotope of cesium. The element rhenium exists as 2 stable isotopes and 18 unstable isotopes. So the question asks, the nucleus of rhenium-185 contains, so we're just talking about the nucleus, so it has protons and neutrons. Rhenium is element number 75, so we know it has 75 protons. That eliminates C as our answer. If we subtract 75 from 185, we get 110. So rhenium-185 has 75 protons and 110 neutrons. And we're going to finish up this slide presentation with this question. Which of the following statements are true? The number of protons is the same for all neutral atoms of an element. That is correct, because protons give an element its identity. And so if it's the same element, it has to have the same number of protons. Let's look at statement 2. The number of electrons is the same for all neutral atoms of an element. Notice it said neutral, which means protons and electrons have to be equal. Since we're talking about an element, it must have all the same number of protons, so it must have the same number of electrons as well. So statement 2 is correct as well. How about the last one? The number of neutrons is the same for all neutral atoms of an element. That statement is not true, because you can differ in number of neutrons and still have the identity of that particular element. You may not be as stable, but you will have the same identity. This concludes lesson 2.5. Next time we're going to talk about molecules and ions and the ways that we can represent those.